Hey guys, and welcome back to the channel. Today we're going to look at Advent of Code 2023 day 4. So the weekend is over, we're back at easier tasks. Today we got a list of scratch cards and each of them had 2 lists of numbers. So the first list is the numbers that win for that card. And the second one is the list of numbers that were scratched off. And we need to find out which numbers that were scratched off were also winning numbers. So for example, 83, 86, 17, and 48. And then we need to find out the value of each card. So the first match makes the card worth 1 point, and each match after the first doubles the value of that card. So we'll have 1, 2, 4, 8, 16, and so on. And what you should see there immediately is those are powers of 2. So one neat little trick that you can do when you have powers is you can just do left shift operations. Looking at the binary representation of 1, 0, 0, 0, 1. We have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So it's 2 to the power of 0, which is 1. And if we now do a left shift, we move every bit in there to the left, which will then be 0, 0, 1, 0, or 2 to the power of 1, which is 2. Doing that again, we will have 0, 1, 0, 0, or 2 to the power of 2, which is 4. And that way you can do powers of 2 quite easily and really fast. Now let's quickly look at the code. I've got the number regex again. That time I made it static so I can use it in the initializer. If we would just use the numbers now, we would also parse the card number, which we don't want to. So I first looked for the colon index and only used the string after the colon. Then I split the remaining string with our separator, took all numbers from the winning side, took all numbers from the scratched side, and stored the winning ones as they said, so we don't always need to iterate through the array. And then I looked at each row, started at 1, so 1 is the number we'll shift. We need to do 1 here because the binary representation of 0 is just zeros, and if we shift 0, nothing would actually happen. Then I went through every value that was scratched off, checked whether winning contained the value or not, and if it contained the value, we did the bit shift. Now the only thing we need to keep in mind is we should actually start at 1 being the first match. We currently start 1 being the 0th match, so we'll always be off by 1. That's why we need to divide in here. Then we print the result and we're finished with part 1. So now in part 2 I should have listened to my own advice and actually I should have listened to my own advice and actually read the instruction. Now for part 2, I should have listened to my own advice properly and read. Now for part 2, I should have listened to my advice and read the problem description properly. However, I didn't, did something different in the beginning, wasted quite some time. So there's no such thing as points, but you win more scratch cards and they are equal to the number of winning numbers you have. So you just need to count how many numbers won. And for each number that won, you will get a copy of the scratch cards below the winning card. So if card 1 had 3 winning numbers, we would get a copy of card 2, card 3, and card 4. If we run out of bounds, we just ignore those cards and won't do anything. And the only thing left is calculating how many total scratch cards we end up with, including the original set of scratch cards. So we still have the same input we parsed at the beginning. We've got the extra array card amount that just keeps track of how often we have one specific card. So if we wanted to know how often we currently have the third card, we would just say card amount at index 3. Now we iterate over every card and then just sum up how many numbers have won. If we haven't found a card, we will just continue. That's to make sure that our range is valid, because if the lower bound is bigger than the upper bound, Swift will crash. And then we make sure that we will not exceed the input array, get the new index, and just increase how often we currently have that card. And all that's left is summing up the amount of cards we have. Alright, that was my solution for day 4. I hope you learned something or at least had some fun. If you enjoyed watching that video, I would appreciate if you gave it a thumbs up, and see you tomorrow.